In this video, the background of each slide represents the application of predicate logic in various fields. Predicates are the statements which are neither true and nor false unless the values of the variables in that particular statement are determined. For example, if we consider x is a number which is divisible by 4 and we say this line in the form of a statement like this: x is divisible by 4, it is a statement which is neither true nor false until x value is determined. Such type of statements are called predicates. So by the definition of the predicate, logic is a first-order logic. Predicate logic is a fundamental tool for the knowledge representation in AI. It is the predicate logic is very useful component in building the intelligent systems and understanding them and find out the reason behind each and every logic and to understand the complex real-world knowledge. So first of all we understand what is logic. Logic is the study of reasoning and argumentation. A logic is something which helps us to evaluate the validity and the correctness of the statements or arguments given. There are different types of logics. So the first logic is proposition logic. A proposition is a statement which is either true or false but not good. For example, sun rises in the east is a statement and a proposition because sun rises in the east is true and it is a universal truth which is always true. Logical connectives are the operators which happen between two complex propositions. Some of the examples for the logical connectives are consumption, that is the end operation between two propositions. Second one is disjunction, which is also called as OR operator, and it is also happens between the two propositions. Next one is NOT operation, which reverses the truth value of the particular proposition. If a particular proposition is true, then the NOT operation needs the true as false. Then the compound proposition. A compound proposition is something which is the combination of two or more valid proposition. These compound propositions are connected by the logical connectives. The next one is truth table. Truth table is a table which represents the truth values of each and every proposition. Logical operators are an and organ and NOT operations, as we studied about, and the truth value of a proposition is the value that represents the given proposition is true or false. So go through and false are the truth values that are given to the premises or a proposition. Inference is a process of deriving new propositions from already existing propositions or premises. So the rules and principles of propositions and the premises will make more valid inferences. Next type of logic is deductive logic. Deductive logic is something which we can determine the final true value of the premises, truth value of a proposition based on the truth values of the premises that are introduced to form a proposition. If the premises in the proposition are true, then the final truth value of the proposition will be true. Otherwise, if the premises that are in the proposition are false, then the truth value of the entire proposition becomes false. Next type of logic is inductive logic, which is similar as deductive, but it cannot conclude the truth value of the proposition based on the truth value of the premises in the preposition. It determines the truth value of the proposition, but it cannot conclude that it is the final truth value of that proposition. Fallacies are the propositions whose truth value is always false. That means the root value of a given proposition is always false, irrespective of the premises in it. Next one is predicate logic, which is as similar as propositional logic, but it extends the propositional logic. Predicate logic is known as first-order logic. Fuzzy logic is a logic which determines the degrees of truth rather than just saying the truth value of the particular proposition is true or false. Mathematical logic. Mathematical logic is the proof or theory that proves the validity of a particular proposition mathematically with a proof. Here we can see the proportional logic versus indicate logic. Already we know that predicate Logic extends the properties of propositional logic. Propositional logic is that the given proposition must be either true or false. So in predicate logic we say for a given proposition we cannot say it is true or false until the given variables in that proposition are determined. So we can say that predicate logic is more expressive and it also very useful for the knowledge representation than the propositional logic because it states the truth value of the proposition after knowing the values of the variable involving in it. Predicate larger contains the quantifiers like belongs to. For all and it also determines the scope of that particular root value using quantifiers, but propositional logic does not contain any quantifiers but it contains the logical connectives like an organ and not. It does not contain any variables, functions or quantifiers to determine the scope of the truth value. Predicate logic also involves functions and the quantifies variables in its syntax, but the syntax of the propositional logic is very simple, involving the connectives which are logical. That's it does not contain any quantifiers in the syntax, but predicate logic involves all the above. Syntax of the predicate logic. Syntax of the predicate logic involves terms, predicates, quantifiers, connectives, parenthesis, variables, and constants. Terms in the predicate logic represent objects or variables or functions combined together form a predicate. Predicates represent the relationships or properties that each variables and functions involve. Quantifiers are to express the statement about all or some things. Example for the quantifiers are for all, there exists, belongs to, etc. Predicate logic also involves connectives like and or and not, implies, double implies, if and only if, etc. Constant and variables in predicate logic. So we consider the names, numbers, some objects or the propositions that are involving in the predicates are considered as constants. For example, Elisa is a name which is considered as constant in the predicate logic, and the number 42 is also considered as constant in the predicate logic. Variables are the arbitrary objects which store some value in them. For example, x, y, z are considered as variables in the predicate logic. Functions and function symbols in the predicate logic, as we studied above. Predicate logic involves some functions in. We can see the symbol of a function here show, and if we consider a function call subtraction, so we can write it as sub parenthesis. In the parenthesis we will write some of the arguments on which we have to perform that particular function. Here we can see some of the examples for the functions, like squaring of a number involves square function. In the parenthesis we need to pass a number which we need to square. Here you can see one more example is to concatenate two strings. Concatenate is a function which takes two arguments, hello and word. For example, the result of a concatenation function is hello world. Atomic formulae in predicate round the component. Atomic formulae are said to be predicate arguments, etc. Predicates are the symbols or names that represent relationships or properties that can be true or false, and the arguments are the terms on which we perform certain functions. For example, consider equals predicate. Predicate is a relationship, so here equals is considered as function. So in the parenthesis, if we pass two variables, that is a and b, if a and b are equal, then it returns true, otherwise it returns false. These are considered as atomic formulas that are formed by predicates and arguments. A well-framed formula in predicate logic consists some rules to be followed while constructing a formula in predicate logic. So some of the rules are the following. First one is involving parenthesis. When we use functions in the predicate logic, variables should be compulsory used in framing the formula. Logical connectives should be used. Quantifiers should be present in that formula. Functions should be the part of predicate formulas. Clarity and consistency should be maintained in the formula so that Examples for inference and rules that are to be followed with proofs. Some of the inferences are modest ponens and modus tollens. Modus ponens. Consider two premises. Tata P implies Q in P. If we say that if P then Q in P is true, that means automatically Q also be true. Let's simplify these complex statements with an example. Consider an example that if it rains then ground becomes wet. If I say it's raining then ground becomes wet will be true. Consider another example. If I study I will pass the exam. If I say I studied then I will pass the exam will be true. Modus tollens. If I say if P then Q in Q is false then automatically P becomes false because Q is dependent on the P. The truth value of Q depends on P. If P happens then Q automatically will happen. Consider an example. If it is raining then the ground becomes wet. If I said the ground does not become red, that means I made Q into not Q, then automatically it is raining becomes fox. That means the truth value of P also becomes false. We can use predicate logic in the resolution also. Here are some resolution steps. First, we need to convert the formula and its negation into clausal form. Then we need to negate the goal formula, the formula you want to prove or dispute. Combine the clauses from the formula and the negation of the goal into a single set of clothes. Apply the resolution tool. Derive new clauses by resolving steps of complementary literals from different clauses. Consider an example in which we can see how resolution works in predicate. Suppose you want to prove the validity of a formula that for all x where x is available of parent of here represent that parent is a function and function has its arguments. So here a arguments of the parents are x Mary, that implies love of x Mary. Here loves is also a function and the arguments of the function loves is x Mary. Here you will convert this formula and its negation into clausal form. Combine them into a set of clauses and apply resolution to determine if the original formula is valid or not. So we can say resolution is used to say whether the formula written in a predicate logic is true or not. Predicate logic is very useful in knowledge representation and it is also used in resolution. There are many applications for the predicate logic. We can use predicate logic for knowledge representation, and predicate logic is also useful in the following fields: artificial intelligence, expert systems, natural language processing, database management system, knowledge graphs, somatic webs, machine learning, planning, reasoning, mathematical formal system, expertise and knowledge management, quality assurance and verification, robotics. Predicate logic is useful in resolution. Resolution is a fundamental rule of inference in predicate logic. Here resolution user for the class form conversion, reputation by contradiction, resolution strategies, and we use resolution to prove the validity of predicates and quantifiers. The application of predicate logic is very important because it is useful in more fields. Moreover, it is useful for the knowledge representation which is essential to design expert systems, and it is also useful in the new technology called natural language processing, artificial intelligence, and robotics, which are future booming technologies. These are some insights about the predicate logic. These are useful file.